All right, welcome back, Kiril. All right, do you remember what we've done last time?
Um, Functions, modulus, arithmetic. Uh, yeah, I think that's it, to be honest.
Yeah, we looked at numbers. We did arithmetic and algebra with numbers, and then we saw that we there were also strings and booleans, and we were able to do arithmetic with strings and booleans. Okay,
Right.
to get us started today, at least for this session, we're gonna run through some exercises just to get you comfortable with typing things into your keyboard and applying what we learned last time. So could you pull up Pirate and share your screen with me?
Okay. Hello?
Yep. Okay. I'm gonna give you some problem. I'm gonna try to annotate on your screen. Let's hope this works. It doesn't always work on Zoom. Okay. Uh, let's get- okay, so here's your warm-up question. Define a function that doubles the given number.
Um,
Okay. So let's say you wanna, how do we decide what number to double?
um, Input,
Inputs. Okay, so in mathematics, like in real life mathematics, when we wanna apply a function, how do we apply that function? How does that look like?
substitution.
But yeah, but in mathematics that you do in real life, not in programming, how would we apply a function?
Well, we'd have values and we'd substitute them, as the
Okay.
variable.
Okay, so for functions, we don't actually do like n equals 3. There's a different way of doing this.
Right.
So the n needs to come from somewhere. It's not equals. We don't use equals for this.
Huh?
Yeah, so we can remove the first line. So remember, a function has three things, right? A function has a name. It needs to produce an output, but it needs to take in input, right? How do we say, how do we specify the inputs of this function?
Um, I don't know.
Okay, so after the double, right, opening parentheses.
Ah, right. So you
Yes.
can just have N here. Forgot.
Yep. There's one more thing missing. Let's run it and see if it gives you a hint. Yeah.
Missing colon. Um,
Nice. Yeah. We just doubled the number. And how do we check that this is correct? How do we apply this function?
Define N.
Yeah, well, we just defined it, right? But how do we
Right.
how do we use this?
Well, would you not just say N equals whatever number?
Ah, no. There's a different way of doing it. So like mathematics in real life, how do we apply a function?
You would give N a value.
And how do we do that?
Um,
Okay, I'll give you a hint. First, we need to refer to the name of the function. So what's the name of the function we're
ah,
trying to apply here?
double
Double, okay. So function takes in inputs. How do we give double a function the input?
equal sign or
Is
no?
non-equals.
Parenthesis.
Yes, exactly. Now let's run
Uh-huh.
this. Yeah. So notice how line 8 and line 4, they mirror each other, right? They look the
They
same.
do.
And when you're passing 2 into the parentheses, and takes on that 2. You see that?
It does.
There's no equal sign going on here.
Right.
Yeah. Okay. So yeah, in mathematics, we call this applying a function, but in programming, we say we are calling a function. All right. Okay. So now to test this is kind of troublesome, right? You have to write it out, on line 8, double two, and then you have to click run, right? It's kind of complicated. There's actually an easier way to test whether or not this is working. So can you create a new line after line 5 and write where? That's WHERE, colon. And then on a new line, let's write double, open parentheses 2, space, is, is, space 4. And let's delete line 10. Okay, let's run this and let's see what happens. Oh, you see that?
Okay.
Yeah. So we can write tests, which let's just check whether our function is correct. Um, you can also write more than one test. Could you write a second test for double? Just create a new line there. Yep. Great. Okay. So that's it for a warm-up question. I was just, making sure that you refamiliarize yourself with the syntax of how to write a function as well as how to test. And so I'm now gonna give you more stuff. Okay, let me pull out my next question. Okay. Are you familiar with Pythagoras theorem?
I am.
Good, 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 good. Okay, this is your next question.
That assumes two numbers, computes the distance of points to the origin. So would this just be like the distance formula?
Okay, and what would that be?
Um, we'd have how would I do a square root?
Ah, good question. Okay. Okay, since you already asked, I'll tell you. So, you remember how we saw modulo and nummin, nummax last time?
Right?
So, these names, these are functions. They have names, but how do we know what their names are? Right? How do we find out about these things? So, in real life, when we're learning a language, we have a dictionary, right? When we see a word we don't understand, we use the dictionary to look it up. Likewise, in programming languages, there are also dictionaries, and we use them whenever we don't know something or want to find out about something. So I'm going to send you the relevant dictionary here. Zoom
I have
chat.
it.
What the? Oh, wait, did I show this to you last time?
Yeah, you did.
Oh, whoops. Okay, I don't usually show this to people this early, but okay, yeah. Okay, square root is somewhere in here. You gotta find it. You
Arithmetic.
can use like Control F or something to help you.
Um, nope.
So a faster way of searching, if you're going to look top to bottom, you can scroll on the left-hand side. If you look at the left-hand side, you get a bunch of indices. Oh, oh, you searched up root. Okay. Oh, okay. There's another way. So if your name is close, but it's not exactly correct, which is why it's not showing up. Okay, could you click on the left-hand side, could you click on Pirate and then built-ins and libraries? Uh, and then numbers, 3.1.2. You see that?
It's
So on the
yeah,
left-hand side, there's a bunch of
not
names.
operators, sign, sign, work, sign. Yeah, okay, I had a feeling
There we go.
of okay, I have to square them too. I could just multiply them together, but uh-huh. So can I use
Uh, no, you can only use round parentheses. Square brackets mean something different here.
or could I not like
Um, it doesn't look like that. Not in this language. So
uh-huh.
multiplying by itself is fine.
Um minus zero, I guess.
Sure.
Because I mean it's just the origin, right? So
Okay.
so you
That's
could
yeah.
could I have this inside of this?
Yeah, you just surround everything in parentheses. Like num squared x squared plus y squared, just surround those in parentheses. Wait, you're trying to pass the results of num squared into num modulo?
Yeah,
So the parentheses should surround num squared, like the whole thing. Just num squared and beyond.
right. Okay, so let's have um square square root.
So read the message carefully. What is it saying?
Is there a missing colon? Do I need a colon?
Yep.
Uh-huh.
Oh, not there. It says before the highlighted text.
Oh, sorry.
Yep.
Operator. Okay, makes sense. So I guess I could just have zero here then,
Yeah.
since it's from the origin.
Okay, so what are you trying to do with num modulo here?
I'm trying to check that the absolute value of the distance is greater than zero.
Okay. Um, how do we, so you're trying to call the function num modulo, right?
Right.
And how do we call functions? And yeah, how do we call functions? Is that how we call functions?
No, you write fun and then the
No, that's how we
module, right?
define a function. There's a difference between defining a function and using it, right?
Yeah.
Like for example, in double, line 4 is how we define a function, but line 7 is how we actually use it. Right now we're trying to use it. So how would that look like?
Um, well, would it not just be like kind of like next to it
What do you mean?
or
Can you show me how that would
in
look like?
in parentheses maybe?
Yes. Yep.
Okay. We need to add or remove some text. So since I have multiple inputs,
Yeah, so what you did is right, but remember, here, line 17, you're trying to call a function, right?
yes.
Okay. And remember,
Ah,
there's a difference between, yeah.
standalone operator
Okay.
expression.
So here, greater than zero is going to take this whole thing and it's going to produce true or false, right?
Uh-huh.
And inside where blocks, inside your test, you need to write is, so is. So can you write is, not there, after the zero?
It's true.
Yes. Right. So we're checking is the left-hand side, the right-hand side. So is the left-hand side true?
Y is unbound.
So notice how, like in double, line sevens and eights, they're using concrete values, right? They're not using n. You don't see n in line
Hmm.
sevens and eight. Same thing with
Right.
line 14, where we should be using concrete values.
Uh-huh. So let's see. One failed.
So, modulo is not absolute value, right? What does modulo mean in mathematics?
Like the modulus.
Yeah, but that's not what you're looking for right now, right? There's something different from absolute value, right?
Right.
So, what is absolute value in mathematics?
Kind of just like the integer. Or,
Yeah, so it's not modulo. You're gonna have to look into the documentation again. There is something here that's actually an absolute value. And you may wish to control F. If you type in absolute value and control F, it might show up.
right.
That's another option. It's not this one. There we go.
Ah, yeah, no maps.
Abs. Okay, so typically it's in languages it's called abs. So it's
Okay.
easy to remember. Okay, great. Um, Now I want you to notice something. Line 14, we didn't actually call distance.
Did we not?
Line 14, no, we didn't call distance in line 14. So we didn't actually
Right.
test our function.
Okay.
So is there any way we could modify line 14 such that we are calling the function distance?
Um, but before that, you would just like plug numbers instead of X and Y.
Yes, right. If you look at line 7, we say double two, right?
Right.
So can we do something similar on line 14?
So if I would just write double distance to operator.
Well, line 17 was right, but line 17 is outside our where block. So line 13 to 15, I call it the where block. That's where we write our
Uh-huh.
tests, right? So you call distance 42 as a means of testing the function, right?
Right.
But should this really be here?
So can I not call the function after like aware?
So you can, but you wouldn't be testing it. You're just calling it. Whereas inside
Right.
a where block, you're actually testing it. So I kind of want us to test this right now.
Okay.
Okay. So right now we're just calling it, but we're not checking whether or not the value is expected. So line 15. So typically you want to write is, yeah.
Right. So 16 plus 4 or root 20.
Yep.
What?
So yeah, read this carefully. What does it say?
Attempt to compare two rough numbers for equality, which is not allowed. Right. So I would have to like take this whole thing.
Uh, you could, but wait, can you bring back square root 20? That's another way. Read the last paragraph of the feedback.
Or consider using the
S-
within function.
or is roughly. So in our case, I think is roughly will work perfectly well for us. Can we change is to is roughly?
Right.
Okay, this is an idea that we'll revisit in the future, but when you have two approximate numbers, you can't compare them exactly because the numbers are approximate. You have to use is roughly.
Okay.
Yeah. Okay, so right, that's great, but line 14 isn't taking advantage of the distance function we've defined, right? We sort of wrote num square root the long way. Is there a way we can use the distance function instead?
Could we not just say distance and then
Yeah. Yeah, let's do that.
okay, sure.
Okay, so why is it important that we're calling the function instead of writing the guts of the function there?
Aha.
No, that wasn't rhetorical. Why is it that we want to do that?
It's less time consuming and it's easier to like debug, I guess.
That's true. That's one more reason. What happens if the body of the function changes? Let's say like you make a mistake. And it's like, oh, let me fix that.
You have to rewrite it.
Exactly. Or even worse, what if you forget to rewrite it? Then your test
And
is
then
outdated.
yeah.
Yeah. A general truism in programming is that you want to make sure there's no repeated code for the
Hmm.
reasons we've just stated. Okay. So yeah, I'm pretty satisfied with this. Let's now move on to a different question.
Yep.
Let's see. Okay. So last time, like we've been working with algebra with numbers. Now we're going to work with algebra with strings.
Aha.
So I'll give you your next question. All right. So define the header of the function, but I would like you to write the tests before you write the body.
Right. So the condition here is it has to be non-empty and it has to be the first character.
Yes, so assume that the string is non-empty. You do not have to worry about the empty case.
Aha.
Yeah.
How would I extract the first string?
Okay, don't worry about that yet. Can you write can you define everything first except the body? So avoid the body for now. Okay, and then where? Let's write the task first.
Um, how would I extract the first character though?
Don't worry about that yet. Just focus on the tests. You can write the test without knowing how that works.
Where F1
What's S and what's F1?
S is the input, F1 is like the output,
Well, line 23, S means nothing, right? S only means
right?
something in the body of the function. So let's
Right.
recall the testing for double. When we were testing double, what did we pass in?
Uh-huh.
Actual numbers, right?
Okay, so let's just say
Is word a string? Like line 23 word, is that a string?
it
Yes. If you
is
do not write
not.
quotes, it will be a variable. Yeah, nice. Can we have one more test?
Uh-huh. Test for what exactly? Um,
So let's try a different word, something that isn't word. Sure, okay. It just occurred to me that the reverse of word is draw.
yeah,
Um, okay, is not is a totally valid test, but I prefer if you were more specific with the test, because we do know what the first character is, right?
right.
Can we specify what the first character is instead, rather than what it's not? Great, okay. All right. So now we can deal with the body. But then your first question to me was, wait, how do we do this? So we have a string, right? Clearly,
Hmm.
we need to do something to that string, but we don't know what we can do. So how do we find out?
This.
Yeah, well, not yeah. So we need documentation, but not numbers. We need to navigate to a different page in our dictionary. Is there a page just for strings? Aha. Okay. So there are two functions here that will help you. Either one will work. I'll give you 3 minutes to try to find it. Your time starts now. And I'll give you a hint if you can.
Um, right. This one, right?
Ah, you found it. Yes. Okay, how do we use that?
Do we have to say is, or can we just
No,
write?
no. So the check here is just showing you like how string caret works. So it's saying like string caret ABC of one is B. But when you're actually using it, you do not have to write is.
Uh-huh. Okay, how do I have S?
So like in when you write the distance function on line 11, how did you use x and y?
I gave it an actual value.
Well, not in line 15, line 12. Line 12,
And
you
that's,
could
oh
use x
yeah,
and
you're
y,
just
right? Yeah, same thing. So yeah, algebra with strings.
interesting.
Yeah.
S. Right.
Okay, let's run it. Let's see if it works. Oh, well, you don't have to write that anymore. Remember, you have your test on line 24 and 25, right?
I do.
Yeah, so yeah, that's actually why we did that, so we don't have to spend extra time to test it. Just click one button. Yay! Hooray! You did it! Okay,
Okay.
our Zoom session is gonna expire, so I'm gonna close this one out and send you a new link on Gmail, okay?
Okay.
All right, see you in a minute. All right, I'm gonna give you your next question. Uh, okay. Whoops. Okay. Do you see it now?
Hmm.
Okay, good luck. So same deal. Write everything except the body. I want you to write the test before the body. Okay, good luck.
Um,
Sweet. Okay. Now onto the body. Good luck.
okay.
Oh, that's a good try. That's a good try. If only. If only. That would work in Python though.
Mhm.
Okay, so yeah, well, so we can do negative numbers. So what must we do instead?
Find the length and then
Ah, you gotta get the length. Okay. How do we do that?
oh oh find what?
Wait, you said length, right?
Yeah, oh, okay. I see it now.
Oh, scroll up a little bit. It's at the top of the screen.
Right, string length.
There we go.
And like instead of the this I can have like my variable.
Oh, sorry, I'm blocking your screen. Let me remove that. There we go. Nice.
Find greater index string. So -1.
Nice, yes. Yeah, because we programmers start counting from zero, right? Yeah.
Uh, they're missing colon.
Okay. The error message is not correct. It's just a white space problem, so I'll just tell you.
I mean, it works now.
Yeah, congrats. You did it. Okay, that
Thank
was
you.
like that was very fast. I was not prepared for this to be done so quickly. Okay. I don't know if I did this with you. Last time did we talk about truth tables?
No.
Okay, yeah. I don't think I did. Okay, I'm gonna share my screen in a moment. Could you stop sharing yours? I'm gonna explain something about Booleans. Let me pull up a picture. Where's my Huh, that's weird. Oh, this will have to do. Oh my God. Sorry, give me one sec. I'm trying to find the picture that I used for. Oh, I found it. Okay. Right, now I'm gonna share my screen. Let me know once you see it.
Okay, I see it.
Okay, I don't know
Uh-huh.
if you. Okay, this is very daunting. I know it looks daunting, but it's actually very simple. Let me explain what's going on. Remember how we saw true and false last time? You remember that?
Logic gates.
Yeah. But do you remember true and false?
I do.
What's true and false?
0 and 1.
Yeah, and what does that evaluate to?
What do you mean?
So true and false. It's the same way we do 1 plus 1 equals 2. What does true and false equal to?
True.
True and false equals true?
Oh no, false, false, false. I remember.
False, right? Okay, so how do we know it's false? So first you find out the truth table for the Boolean operation you're using. So n, we look at n. Then we go
Right.
to true. So 1 is true, 0 is false. So true, false, output is false. Okay. Okay, how about true or false? What does that evaluate to?
It evaluates the true.
To true, right? So look at the or table. True, false is true. Okay, so conceptually, Boolean operations are like functions in the sense that they have inputs and outputs. I say conceptually because there are some things behind them that makes them not actually functions, but we'll get to them in the future. Okay. Um, Remember how I said that computers are a bunch of zeros and ones?
Right.
Okay, these are the zeros and ones. These are it. So, below the names, there are diagrams. These are physical logic gates. These are physical embodiments of the Boolean operations. Our computers are made with thousands, millions, billions of these tiny, very, very tiny things. These
Right.
things, they take in wires with electrical signals, and the wire that comes off the other end, it processes the electrical signals, and depending on its logic gate, it may emit an electrical signal. In other words, it's taking zeros and ones and changing them. Our computers are billions of these things, taking in zeros and ones and changing the zeros and ones. It's stirring the soup of zeros and ones, and that's what makes computation possible. Okay.
Hmm.
Now, for our purposes, we only need to know three, not, and or. As programmers, we only need to know these three Boolean operations. Uh, Unless you want to get into like really performant algorithms, you have to know more. Um, or low-level programming, if you get into low-level programming, you have to know more. Okay. Now, just to explain N and R, the mnemonic is that for N, if there's at least one false, the result is false. False. So if you look at each row, whenever there's a zero in the input, the output is zero, right?
Hmm.
For OR, if there is at least one true, the result is true. So each row, if there's one, then the output is one. Not, it
Right.
just flips the booleans. Okay.
Okay.
Since we're on this topic, okay, you don't need to know the rest, I'll just explain them to you. XOR means exclusive OR. Um, Notice how the double ones, like it's the same as OR, but when it's double one, their output is zero. Okay.
Right.
Yeah. Um, why is it like this? So, if you think about it, or what or is saying, let's say you have an apple, and I ask, do you have an apple or a banana? You say yes, I have an apple, right? That's what or
Right.
means. If you have both an apple and a banana, you'll say yes, I have an apple and a banana. Yes to both. But for XOR, let's say my mom is asking me, do you want ice cream or waffles? And I say I want both ice cream and waffles. My mom will say no, you can only have one.
Interesting.
So it's exclusive,
Right.
exclusive OR. So yeah, that's an example. I'll give you a real world example of and as well. Let's say you have an apple, only an apple, and I ask, do you have an apple and a banana? You'll say no, I only have an apple, right?
Right.
Okay. So nan means not and. The and means not. It's the and, but all the outputs are flipped. You see that?
Hmm.
Yeah. And nor, same thing. It's not or. It's the same as or, but all the outputs are flipped. X nor, it's it's the same thing as XOR, but all the outputs are flipped.
Right.
All right. Again, you don't need to know any of these except not and an or. Um, you will need this for the next thing I'm gonna give you. I'm gonna stop sharing my screen. Could you share yours again? Next challenge. This one, this next one is quite challenging. Right, let me write this down. So we just practiced algebra with strings. We are now practicing algebra with booleans. Oh, sorry, I should say call this function implies. I don't know if you studied logic in school, but this is a classic logic operation.
Function consumes two Boolean values. Form Sunny and Friday. Its answer is hashtag true.
Oh, it's just hashtag true is just true. Ignore the hashtag.
If Sunny is false, then Friday is true.
Ah, you're thinking about how to solve this, right? Don't worry about that yet. Just focus on defining everything, write test, and then we'll deal with the body last.
Okay.
Okay, wait. It looks like you're writing the solution. I want us to focus on the test first.
Right. Okay.
Okay,
Friday,
so let's look at line 31, right? When we write test, what's the first thing we should write?
the function.
Right, we should call the function, right? By writing its name. Okay. Okay, what's Friday?
Um, Variable.
A variable. Okay, but right now it's a variable, but remember, if you look at line 31, right, when we pass in a string, we actually pass in a real string, right? Yeah. But is our function taking in strings?
No.
Okay, what do they take in?
Um, it consumes Boolean values.
Oh, Booleans. Okay, what are Boolean values?
True and false.
Well, not there, right? Line 35, we take in parameters, which are like, for example, line 28, S1, right?
Uh-huh.
So line 35 should only take in parameters, not concrete values. So what you had just now was right, actually. Friday and sunny.
Right. Okay.
Oh, actually, I know, okay, this is gonna sound weird, but can you swap Friday and sunny? So it's sunny and then Friday. It may not seem like it matters, but it matters.
Right.
Okay, okay, there
Okay.
we go. All right, so
Sounds
implication, what do we pass in? It's not a string. What should we pass in instead?
um Friday.
Well, line 31, when we call string last, we don't pass in S1, right?
We don't.
Yeah, we pass in an actual string. So to write booleans, you don't need double quotes. You just write true. Yeah, so these are special. These are not variables. It's a boolean value. Okay, so sunny is true. Okay, is that it?
Um okay, but it's true that it's sunny and Friday.
So you're trying to say true for both?
I'm trying to say true for like, okay, if it's sunny, then it's Friday.
Don't worry about the answer yet. Just worry about what to pass into implication. So right now you're passing in one thing, but how many things does implication take?
True. Two.
Two things, right? Okay, so what's the Boolean value for the second thing? Okay, let's say it's false. Okay, so what's the answer of implication true false?
Its answer is true if sunny is false, or Friday is true. What? Its answer is true if sunny is false.
Is sunny
Uh-huh.
false?
No.
Okay, sunny's not false. Is Friday true?
No.
So neither are true. So remember the truth table. When neither are
Right?
true on the OR Boolean operation, what's the answer? False. Yes. Okay,
Right.
let's write more tests.
But it's right. True, true, I guess.
Sure?
True, true.
Okay.
Okay. And that's kind of all the options.
Mm-hmm. Why is it false?
Well, what the gate is this and?
No, it's not Anne. Remember, its answer is true if Sunny is false or Friday is true.
So it's true?
Okay, why is it true?
Because sunny is false.
Great. Okay. All right.
It's a
What's
mouthful.
next?
Okay. The end and then the body,
Okay,
right?
so whenever you can write all possible test cases, write all possible test cases.
Uh-huh.
So Boolean values, since there are only two, there's very, very few test cases for this, and let's write all of them. We wrote three. There's actually one more.
Right.
True false is the same as the first one. Yes. Great. Okay. By the way, I don't know if you noticed this, but we just encoded the truth table into our tests.
We did.
Yeah. Remember, like programmers, we encode we encode information to data. This is a form of encoding. Truth table is a form of information, and we have put that into our tests, and we can run it to check our work. Great. Okay, let's write the body now.
Uh-huh. Okay, wait. So do I put the parameters here?
Okay,
No, it has to be
so
some sort of operator.
right now you're calling implication inside implication, right?
So okay, what operator would I use here?
Okay, well, it depends what you're trying to achieve. Remember, the answer is true if Sunny is false or Friday is true.
Maybe
Sure.
if sunny, true, and the word.
Well, if you got to pick one, you can use both.
I would say or
Okay.
Friday. No, this is the inverse. Sunny false.
So you have to write
True.
Sunny is false. So you got to write is, Sunny is false. Okay.
True.
And then you got to write Colin to open the body of the condition if it's true. So if the condition is true, what do we produce?
True, right?
Okay, it's true.
Do I just write true?
Yeah. All right, and then you got to write else. So if the condition is not true, if it's false, colon and then new line, what should the answer be? False. Okay. Okay, so
Okay, makes
for
sense.
every time you have a multi-line expression, so if it's a multi-line expression, you have to end it with an N. So create a new line after line 39 and write ENDN.
Uh-huh, okay.
Yeah. All right.
So
Let's run this.
that's just syntax then.
Yep.
Testing must be used inside
Oh,
check or
sorry, it's not is it? Can you change is to double equals? So equal equal? Sorry, my bad, my bad. Okay, yeah, that's right. Nice.
okay.
Hooray. Okay. Um, could you save all of this to a TXT file?
Right.
Okay, I'll let you do this after our session ends. I do have to wrap up now. Okay, to summarize what we've done, we have, or you could also, oh, if you're gonna do that way, could you stop sharing your screen? Just in case, I don't want you to leak anything, any personal details.
Um, well, yeah, I just have here. Let's have it here.
Okay, so yeah, let's start wrapping up here. And yeah, so to summarize what we did, we just applied what we learned in the first session, and we have done algebra with numbers, but also with strings and booleans. There is
Hmm.
actually a way to improve our solution for implication, and we'll get to that next time. Do you want homework?
Um, Not yet. I think,
Okay. Yeah, no worries. Whenever you're ready.
yeah,
Uh,
because I,
we'll
I
save it
think
for next time.
homework in this case would be like more constructive, as in like homework relating to the project.
Okay. All right. We'll pick it back up next time. I see that you're pretty familiar with all this. Just to let you know what the trajectory is in the near future, since you're interested in like more data analytics, we're going to move towards the kinds of things we do in programming that would be processing data.
Right.
All right.
Okay.
That's what we're building up towards. Okay. All
Wait,
right. I hope you learned something. Yep.
yeah, just before we wrap up here, um, when can you schedule the next session?
So you can do at most once a day. That's
Right.
currently the rule.
Uh-huh.
Yep.
And I think I lost like the form and the calendar thing.
Yes, you use the same booking link as always. Yeah.
But no, I lost it. That's
Oh, you
like
lost the
the issue.
link.
Yeah,
Okay,
yeah.
I'll send it to you again.
All right. On Gmail, right?
Yeah.
Okay, thanks.
All right. All right. I'll see you later, Kiril. I'll see you
All
next
right.
time.
Goodbye.
Bye
Goodbye.
now.
Thanks for this.
Mhm.